All right, let's talk about EC2. It's the absolute backbone of AWS. But we're going to go way beyond that simple textbook definition of a virtual server. We're diving into what it's really like to run things on EC2, the operational side. You know, what happens when things break and you're the one who has to fix it. So let's get into it.
So picture this. It's 3 in the morning. Your phone starts blowing up with alerts. The app is down. Customers are seeing error pages. This isn't some theoretical problem in a textbook. This is the reality of running a real system. So where do you even start looking? The problem is somewhere in that cloud stack, and it's our job to hunt it down.
And the very first place we should look is the engine itself, EC2. And for a minute, let's just forget the phrase virtual server. A better way to think about it is this. EC2 is the raw CPU and RAM that you are renting from AWS. It's the engine that's supposed to be running your code. And right now, our engine has completely stalled.
So, to figure out why, we're going to do what's called a postmortem. We're going to break the whole system down piece by piece and look at each component as a potential suspect in our outage. It's like detective work, a methodical investigation to find that single root cause, and we're going to start with the machine itself.
Okay, so suspect number 1. Did we even pick the right machine for the job? I mean, a super common reason for apps to fall over is that the server was just underpowered. It couldn't handle the traffic. And this brings us to a really crucial idea. EC2 instance types.
So AWS gives you this whole menu of instance families, and each one is built for a specific kind of work. You've got your general purpose ones, like the T&M series, which have a nice balance of everything. CPU, RAM, networking, they're great for things like web servers. Then you've got compute optimized, the C family, which are all about raw CPU power for intense calculations. And on the other end, memory optimized, the R family, which are packed with tons of RAM for stuff like in-memory databases. Now, if our app was trying to do heavy data processing on a tiny T3 micro, well, we might have just found our culprit right there.
And this right here is absolutely key. Choosing an instance type isn't just some minor detail you click on when you're setting things up. No way. It is a fundamental architectural decision. Matching the hardware to what your application actually does is one of the most important things you can do to keep it stable.
Okay, so let's say we picked the right hardware. The machine is powerful enough. What's our next suspect? Well, it's the software itself. Was every single server we deployed running the exact same, perfectly configured code? Because even a tiny bit of inconsistency between them is just a recipe for disaster. And the solution to this is something called a golden image.
In the AWS world, this golden image is called an AMI, which stands for Amazon Machine Image. Think of an AMI as the master blueprint for your server. It's not just the operating system, it's everything. The OS, your actual application code, all the libraries it depends on, every single configuration file. It's a perfect snapshot of a server, ready to go.
And the strategy here is actually really simple, but it's incredibly powerful. First, you start with a plain, basic AMI from AWS. Then you carefully log in and install and configure everything your app needs to run perfectly. Once it's exactly right, you take a snapshot of it, creating your own custom golden AMI. From that point on, every new server you launch is an identical clone. This completely eliminates configuration drift, that nasty problem where servers become different over time as a source of errors.
All right, our hardware is correct, our software build is consistent. What else could possibly go wrong? Well, can anyone actually reach our server? The next step is to investigate the network. And in AWS, that means we're looking at security groups. You can think of a security group as a virtual firewall or a bouncer at the door, controlling every bit of traffic that tries to get in or out of your instance.
Now you have to get this one core principle about security groups. It is non-negotiable. By default, they deny everything, all traffic. Nothing gets in and nothing gets out. It starts as a completely sealed box. It is up to you to poke holes in it by creating rules that explicitly allow the specific traffic you need. It's what we call a secure by default model.
The rules are split into 2 directions. You have inbound rules, which control the traffic coming to your server. So for our web app, we need a rule that allows web traffic on port 80 from anywhere on the internet. Then you have outbound rules, which control traffic leaving your server. It's pretty common to just allow all outbound traffic, so your server can, download software updates or talk to other AWS services. A single typo in one of these rules, that could be the entire reason our app is down.
So we've gone through our list of suspects: the wrong hardware, inconsistent software, a messed up network rule. But the real fix isn't just about patching the one thing that broke. The real fix is to build a system that is just naturally resilient to these kinds of failures. So let's redesign this thing so it can actually survive an outage.
And the absolute heart of this new resilient architecture is the auto-scaling group. This service is like a manager for your fleet of servers. Its whole job is to make sure you always have the right number of healthy instances running. If a server stops responding to health checks, the auto-scaling group just terminates it and launches a brand new one to replace it automatically. This is our robot that fixes the 3 a.m. failure so we don't have to.
You configure it with 3 really important numbers. The first is the desired capacity. Think of this as your happy place. This is the number of instances you want running on a normal day. If we set this to 2, the auto-scaling group's main job is to keep exactly 2 healthy servers running, no matter what.
Next up is the minimum capacity. This is your safety net. By setting this to 1, we're telling the system, hey, no matter how quiet things get, never ever go below 1 server. This makes sure our application doesn't just disappear completely during a slow period. It's the absolute floor.
And finally, and this one's super important for your wallet, we set a maximum capacity. This is your circuit breaker. By capping it at, say, 4, we let the system add more servers to handle a spike in traffic, but we prevent it from scaling up to 100 servers because of a bug or an attack. This ceiling protects you from a truly massive unexpected bill.
By the way, if you find this kind of practical, real-world breakdown of how these AWS services fit together useful, this is exactly what we do every day. Hitting that subscribe button makes sure you won't miss out on the next explainer on how to build and manage systems that don't wake you up at 3 a.m.
So, let's put all the pieces together and see how this resilient stack works. A user's request from the internet first hits an application load balancer. The load balancer is the single front door. It then looks at a target group, which is constantly checking the health of our servers. It will only send traffic to the instances that are healthy. And where do those instances live? Inside our auto-scaling group, which manages the fleet, replacing bad ones and adding new ones when traffic picks up. And of course, every single one of those instances was launched from our golden AMI and is spread across multiple data centers for redundancy. This is the kind of architecture that lets you sleep through the night.
So there we have it. We've built this amazing system that's stable, it scales, it can even heal itself. We've solved the 3 a.m. outage problem. But in solving one really big problem, we've actually created a totally new kind of operational risk. We've gone from worrying about 1 server to managing this complex, automated system.
And that brings us to the final, and maybe even scarier question. Your infrastructure is now stable. It won't fall over. But who has the keys to the kingdom? Who's allowed to change those auto-scaling settings? Who has permission to create a new golden AMI? Answering those questions is the next massive step in mastering the cloud. And it's all about identity and access management. We'll see you in the next one.